All right, so let's look at a couple of examples here. So we have um, a graph the quadratic function g of x equals -2 times x minus 1 squared plus 4. So in order to graph a quadratic, even by hand or on a computer, we need to just plot a couple of points. So if we're doing it by hand, we actually probably need 3 points. If we're doing it on WebAssign or wherever you end up doing your homework, you'll just need 2. So first we need to identify the vertex. And so this is in standard form. So the vertex is in here. So change the sign on that one. And vertex is 1. Keep the sign on that one. And the y part is 4. So there's our first point, 1, 4. Now we really just need one other point if we're on the computer, 2 other points if we're completely drawing this by hand. And so you can just plug in any value for x except what is in the vertex. So let's just try 0. Find g of 0. And so -2 times 0 minus 1 squared plus 4. And we get -2 times -1 squared plus 4. That'd be 1. So we have -2 plus 4. That is 2. So our second ordered pair would be 0, 2. And this is actually enough. Now you can actually go, you can pick another point. We can pick 2. And if you plug in 2, you'll find that the other y coordinate is also 2. And this is because we have a symmetry around the vertex. So there are 3 points, and we can look like that. And of course, probably more curved there, but that's okay. That's all you got to do. Just you find the vertex, find another point, and that is enough to graph a parabola. The next examples here, we have a table of values. And on the homework, the first part of this will be to choose the correct scatter plot. And so we're really just looking at these, and most of the time, T in this case will be years after 1970 in this case. A lot of times they'll have you, if T is representing years, they're not having you usually use the actual year. They'll pick a starting time, and then it's the number of years after that. So in our case, 0, 5, 10, 15, so on. So now, if you pick out the scatter plot, you can kind of see where the vertex is. But you can also tell from this. So this one, these values are going down, and then all of a sudden they start going back up. So where you see the bottom, that's going to be our vertex. So let's write y equals, or p equals, or population, a x minus h squared plus k, and we're just going to figure out what a is and what h is and what k is. So we can get h and k from the vertex. So this is 15 years after 1970. So this will be x minus 15 squared plus, and then the k will be the 2200. And so now just pick another point, plug it in for x and y. You pick any of them. We'll just pick this first one. So y would be 4250, and x is going to be 0. And now we can just solve for a. So let's bring that over. We get 2250 equals a, and then -15 squared would be 225. I'm sorry, that's 2050. And so a is 82/9. And so now we can just plug in a in here, and we have our quadratic equation. So 82/9 times x minus 15 squared plus 2200. And that is a quadratic equation that models this data. And so that's really all you have to do. If you need an equation, find the vertex, plug in another point to get the a. If you need to graph, all you do is find the vertex and then find another point, and that will allow you to graph. All right, so the next one we'll look at some higher degree polynomials.